This lesson is on finding common denominators for rational expressions. So in our last lesson, we talked about least common multiples, and we did that because the least common multiple is going to be the same thing as your common denominator. So the beginning steps of this is going to look very familiar. We start out with our denominators, x squared and 3x, and we find their least common multiple. So we look for what they have in common. They have an x in common, so x squared divided by x is x. 3x divided by x is 3. X and 3 don't have anything in common, so we're going to multiply those. X times 3 is 3x squared. That's going to be our common denominator. So we're going to write both of our fractions with a denominator of 3x squared. And now we're going to work on getting an equivalent fraction here. We want to know, what did we multiply 3x by to get 3x squared? Because whatever we multiplied the denominator by, we're also going to need to multiply the numerator by the same thing. So here it's pretty easy to tell that we multiplied x squared times 3 to get 3x squared. So if we multiply the bottom times 3, we'll multiply the numerator times 3. And our new numerator is 9. So 9 over 3x squared is equivalent to 3 over x squared. Then we have the 3x. What did we multiply 3x by to get 3x squared? Well, the 3 stayed the same, and the x became x squared, so we must have multiplied by an x. So we need to multiply x plus 1 times x. And here I'm going to go ahead and distribute my x in and get x squared plus x for my numerator. And now we have two fractions with common denominators. Why would we want that? Well, now if we wanted to add them or subtract them, we could do that. But I wanted to show you something else that our little method over here helped with. If you weren't sure what to multiply by, the fraction that had an x squared needed to be multiplied by 3 to get 3x squared. That's what we multiplied by. The fraction that had a 3x as a denominator needed to be multiplied by x. And so your little cake method here can show you what to multiply by if it's not as obvious. Okay, in this one we have binomials for our denominators, so we want to be sure we factor them first before we look for that common denominator. X plus 1 isn't going to factor, so we're going to put it in parentheses, x plus 1. X squared minus 1 is a difference of perfect squares, so x plus 1, x minus 1. They have what in common? They have an x plus 1. So x plus 1 divided by x plus 1 is 1, and x plus 1 times x minus 1. If we factor out that x plus 1, we have an x minus 1. So here's your common denominator, x plus 1 times x minus 1. And we're just going to leave it like that. We're not going to multiply it back together. So draw your fractions. X plus 1, x minus 1 is what we decided on for our denominator. And we need to figure out what needs to be multiplied by. If we look at this, we might be able to tell with the x plus 1 is there, it needs to be multiplied by x plus 1. Or remember on the last example I showed you, you can just look at that. That's going to tell us that fraction is going to get multiplied by x minus 1. So we're going to multiply the top by x minus 1 and the bottom by x minus 1. If I distribute the 2, I get 2x minus 2. And then we already had the denominator there. The second one, this was x squared minus 1, so it's x plus 1, x minus 1. That means that denominator didn't change, so the numerator is also not going to change. We could also look at this and say it's getting multiplied by 1. Now we have our two fractions with common denominators. Let's do one more example. Here we have our denominators x squared plus 2x. That factors to x times x plus 2. X squared minus 4 factors to x plus 2 times x minus 2. So we're going to come over here, find our common denominator. X and x minus 2 for the first fraction. Pardon me, x plus 2. And x plus 2 times x minus 2 for the second fraction. They have an x plus 2 in common. We're going to take that out. In the first set, we're left with x. The second one, we're left with x minus 2. So here our denominator is a little bit longer. It's going to be x plus 2 times x minus 2. We're going to put that monomial in front, so the x in front. And then we have the x plus 2 that they had in common times the x minus 2. And we're going to leave it just like that. We're not going to multiply it out. X times x plus 2 times x minus 2. That's all of these things here. This is when it's going to be helpful if we look at what does this fraction need to get multiplied by. It has the x and the x minus 2, or sorry, the x plus 2. It needs to be multiplied by x minus 2. So we're going to multiply on the top and the bottom by x minus 2. We'll distribute, so we have 2x squared minus 4x. For this fraction that has the x plus 2x minus 2 as its denominator, it needs to get multiplied by x on the top and the bottom. So we have 5x. And now we have our common denominators, and we can add or subtract whatever we need to do.